In this session, we will start with the new unit, Conducting Materials of Material Science course, and then one by one, Conducting Materials we will study. Okay, so today in this session, we will start the introduction of conducting materials, main definitions. So, syllabus of this unit, conducting material, is like this. General properties of conductor. What are the general properties of conductor? Then electrical conducting materials, copper, aluminum. These are popularly used conducting materials in electrical engineering. So we'll study properties of copper, aluminum and its applications. Then materials of high and low resistivity. So we should not confuse with this word resistivity. In conducting materials, again we can sub-classify conducting materials like high and low resistivity. But that will be conducting only, not resistive materials. Okay. But having conducting materials having high resistivity and conducting materials having low resistivity. So like constant nickel, chromium, alloy, tungsten, canthol, silver and silver alloys. And characteristics of copper alloys also, brass and bronze are copper alloys. So we will see characteristics of copper alloys. Then electrical carbon materials. Materials used for lamp filaments, solder metals and alloys for different types of thermal bimetal and thermocouples. So content is very simple. Understanding is not required at all. Only you have to remember properties of material and applications of the material. Okay. So very simple unit is there. So let us start with the properties, main properties of conducting materials. And you know, for insulating materials also we have seen resistivity. Conductivity and resistivity are two important properties in our electrical engineering. So what is resistivity? How you can define resistivity? Resistance, you know, you are defining resistance like the flow of opposition to the flow of current. But resistivity of material you can define as the ohmic resistance offered by a conducting material of unit cross-sectional area and length. Okay, not only conducting material, but for all materials you can find out resistivity. Okay, so it is a ohmic resistance offered by unit cross-sectional area and length. So resistivity is the resistance offered by a unit length, one length of wire you take, and that area of that one length wire will be one area, means 1 centimeter square or 1 meter square or 1 square unit area. And what will be the resistance offered by that length of piece by 1 and area of 1 square? That is known as the resistivity. So resistivity depends upon temperature. Mainly depends upon temperature because generally temperature is variable. And you know the formula R is equal to rho L by A. So this is the resistivity. R is the resistance in ohm, L is the length of the wire in meter, and A is the area of cross section in meter square. Okay, so what will be resistivity rho? Resistivity rho will be A, cross sectional area. You can just take it this to the left hand side. So A into R divided by L. So you can say that resistivity will depend upon length, cross sectional area. But generally for you can see for particular material, for particular wire, it will not be changed. Length, area you cannot change. Only changing parameter will be temperature. So here temperature will be influencing on resistivity mainly. And of course of what material, what is the atomic structure of that material, what are the properties of that material, on that also it will depend. Then second important property is conductivity, because for conducting materials, conductivity and resistivity are the main properties. So conductivity is the reciprocal of electrical resistivity. So you know the rho is equal to resistivity. So conductivity will be 1 upon resistivity. So conductivity is the reciprocal of electrical resistivity and is expressed in ohm -1 and meter -1, because ohm meter is the unit. Here resistivity unit is ohm meter. So 1 upon resistivity means 1 upon ohm, means ohm raised to -1, and 1 upon meter means ohm meter raised to -1. So we have to remember unit also, and while defining You have to write down units also. So conductivity unit is ohm minus 1, meter minus 1. And conductivity is equal to 1 upon resistivity. Electrical conductivity varies widely from one class of material to another and is the movement of electrical charge from one location to another. So from the name only you can just say conductivity. So conduction starts, means current starts flowing. Suppose this is the wire and you can just see current is flowing from top to downward. So what are the charge carrier movement? That indicates current and that will indicates the conductivity. So it is the movement of charges from one location to the another, from top to the bottom. In metals, the charges carry electrons. So in metals, what are the movements? Movements of the charge carriers mean electrons. At room temperature, conductivity of different material is as follows. Because resistivity depends upon temperature, so conductivity will also depend upon temperature. So for room temperature, because if you will see ambient temperature is hot, then conductivity will be different. So generally it is specified at room temperature. So at room temperature, conductivity of insulator is 10 raised to minus 16. Semiconductor is 10 raised to 2 and then silver is 10 raised to 8. So whose conductivity is higher? Semiconductor, insulator or silver? You can just say silver is 10 raised to 8. So you can say silver's conductivity is higher. Now what are the factors affecting on resistivity? We have seen important factor is temperature. But depending upon the material of that wire, resistivity will differ. So factors affecting on resistivity are temperature. First is temperature. Then alloying, how that conducting wire is made up of, whether it is made up of pure or it is a mixture. So what is the alloy content in that? If it is alloying, then conductivity will be reduced. Then cold work. So you know the cold work means what? That cathode function. So what is the cold work of that material? And then age hardening, because hardening will also change the conductivity. So let us see one by one. So temperature effect you have studied. So electrical resistance of metal increases with increase in temperature. Remember this, because for insulator exactly it happens reverse way. For metal, if you will increase temperature, resistance will increase. But for insulating material, temperature will damage the quality of insulating material. Means what? Resistance of insulating material decreases with increase in temperature. So such questions are important for oral exam. So temperature is having a resistance coefficient of temperature for conducting material. It is positive, but for insulating material it is negative temperature coefficient of resistance. So alpha is positive for conducting material and alpha is negative for insulating material. So remember this, for conducting material when temperature is increased, metal resistance will increase. But for insulating material it decreases. However, the electrical resistance of semiconductor and electrolyte decreases with increase in temperature. So that is for semiconductor and electrolyte and insulating materials also. So rho at certain temperature will be rho at zero temperature. Means suppose you want to find out resistivity at 40 degrees Celsius. So T you can just insert at 40. How you'll find out the resistivity at 40? You must know resistivity at absolute zero temperature and 1 plus alpha T. So alpha is the temperature coefficient of resistance. So coefficient of resistance or temperature coefficient of resistance. And rho zero is what? Resistivity at 0 degrees Celsius. So to find out resistivity at certain temperature, you need to know resistivity at another temperature. Okay, and then you can find out using this formula. Write down this formula, simple problems will be asked. Okay, and now I just confirm about the exam. It seems that your exam will be offline. Okay, so be prepared for offline exam. Come out of the phase from that COVID situation and don't rely that objective test will be there. Otherwise, harm will happen. Disadvantages will be there. So what I am going to tell you, you be prepared for offline test. If you will prepare for offline test and then exam will be online, there will be no difficulty. Okay. Okay, so that is what I wanted to tell you. We have to be ready for the offline exam. So the resistivity vanishes at absolute 0 degree temperature. That we'll see in superconducting materials. Okay. So you remember this formula. And then second factor of affecting, which affects on resistivity is alive. One experiment is there. We'll conduct this when you will come in the lab, physical. Okay, and then you will observe that how you can measure resistivity. Very simple experiment by giving DC supply, measuring voltage and current. We have performed on virtual lab also. So alloys which are homogeneous mixture of two or three different metals obtained by heating. If you want to make a alloy of silver or alloy of copper, then how you will prepare that alloy? You will take two, three metals and then you will mix it and you will make a homogeneous mixture by heating, that means melting and just making a homogeneous mixture, then that is called as alloy. But resistivity of alloy is more than the resistivity of the parent metal. Suppose you are making alloy of copper, so resistivity of copper alloy will be higher than copper. If you are making resistivity of silver, alloy of silver, then resistivity will be higher. So resistivity of alloy will be resistivity of parent material plus this S into Pi. So S is atomic percentage of impurity added. How much impurity you will add in copper? How much impurity you will add in silver? Depending upon impurity content, your resistance will increase. Okay, and rho I increases the resistivity for an atomic percentage impurity. So copper nickel alloy. Example is copper nickel alloy, means you will add some percentage of nickel in copper. Suppose you will add 20% nickel, then resistivity will be different. If you will add 40% nickel, resistivity will be different. So by addition of 1% nickel, resistivity will increase by 1.3 micro ohm. Okay. So that is the example. So factors affecting on resistivity are temperature, alloying, and third is cold work. So in this mechanical distortion of the crystal takes place, the structure decreases the conductivity and increases the resistivity. Now see, if you are considering copper or any material, how it is made, how it is constructed, whether it is hard drawn or cold drawn, means see, sometimes you know that steel annealing is done, heating is done, so that will change the resistivity. So how the crystal is taking place, mechanical distortion in the crystal, because you have studied the domains, you have considered the dipole moments, you know dipole moments are originated in some fashion. Suppose you can just see this arrow, I don't know whether you are able to see or no, but suppose now dipoles are originated from top to bottom, top to bottom. So they are aligned parallelly, but suppose they are aligned randomly, then definitely resistivity will be different. So how this mechanical distortion is there in the crystal, whether you have hard drawn heated that material or no. So structure decreases the conductivity and increases the resistivity. Hard drawn copper wire has a lower conductivity than annealed copper. Okay, hard drawn. So if copper is hard drawn, means wire you are making, copper metal you are just making the wires by heating that, hard drawing it. So it will have lower conductivity than annealed soft copper, and annealed furnace heated. Examples is there. So age hardening is also important factor affecting on the resistivity. Now what is age hardening? It means that metal affected by atmospheric condition and therefore aging takes place. I told you aging effect. In cable insulation or oil, I told you as the aging occurs,